Finding minimum and maximum values. So I have Max from two girls, and I have Minnie Mouse. Minnie and maximum values. Okay. To find these, let's look at a regular equation I call in general form here. F of x equals ax squared plus bx plus c. If I was to complete the square on this, you would basically end up having to factor your a out of the term here. Then you would divide your b divided by a by 2, which makes the same as multiplying by 1/2. So you have b over 2a. So what that would mean is, and I would then square it to get to complete the square, which would be a b squared over 4a squared. If I square these, which I then add to this, I got to add and subtract it in a sense because I'm adding that in here to factor, but also this keeps it balanced, but then I'm going to kick this out, but I'm kicking it out, I'm multiplying it by a, so I put in this a here, and so if I perform the math here where I have this, this a cancels one of those a's out there, so what I have is written here, if you'll notice, this x plus b over 2a plus c minus b squared over 4a is the same thing as, look up here, this is our vertex form where I have an a in front like I do here, I have an x, and instead of a positive h, this says minus h. That's what my x values of the vertex. So basically, and then my k would be this value right here. This is a formula that I could use to help find h and k for the vertex for the maximum and minimum. Oh. So basically, because if you think about it, minus the negative b over 2a, because you have to have a minus here, so you're minusing a negative. Hence, that's where the vertex comes from, negative b over 2a. And then your k would be the same as your c minus your b squared over 4a if you want to take a shortcut. But I got a better way to do that. I want to show you here in a second. This is the why what I'm fixing to show you is true. All right? Because here's how I use this information. I know this here. In a quadratics, the minimum and maximum occur such as this. First off, if a is positive, you have a minimum. And if a is negative, you have a maximum. And the x-axis of symmetry will be this negative b over 2a because that's where the vertex is at. Your x will always be this negative b over 2a. So what I want to do is this. If I go up here and I know this about my formula, a is 2, b is negative 1, and c is 1. Because I don't write a 1 there, it just means it's not there. It's negative 1. And so I want to find where the minimum is at, because I know that a is positive. I'm simply going to go up here and replace the b, the negative 1. I have a negative 1 right here. And 2 times 2, which means it's 1/4. Negative times a negative makes it positive, and 2 times 2 is 4. So at 1/4 is where the x value of the minimum is. Well, if I want to find what the y value is, just plug it in. That's what Rufus was telling me. So go back up here to this equation and plug in the 1/4 for your x. So if I take 1/4 and square it, which is 1/16, minus 1/4 plus 1, I take 2 times the 1/16, which is the same as 2/16 or 1/8. I went ahead and converted the 1/4 to 2/8 and the 1 to 8/8. That way I had a common denominator. 1 minus 2 plus 8 turns out to be 7/8. So the vertex would be at 1/4, 7/8. The easiest way to find the vertex is to do negative b over 2a. That gives you your x value, and then simply plug it into the equation to find the y. And most of the time it will not be this hard. This one was a fraction one to kind of make things a little difficult for us.